The exponential function. Y equals 2 to the x if and only if x is log base 2 of y. Y equals 10 to the x if and only if x equals log base 10 of y. Y equals e to the x if and only if x equals natural log of y. Y equals e to the x and y equals log x are inverse functions of each other. Properties of e to the x. You have your sum property, your difference property, your power to a power property. Then property 4 and 5 just come from the fact that e to the x and log x are inverse functions of each other. If y equals e to the x, then that means that log y equals x. Take the derivative of both sides. I get y prime over y on the left, and then on the right, taking the derivative with respect to x, I get 1. Solve for y prime, and I just found out that the derivative of y is y. Now, that's terrific. That tells us that the derivative of e to the x is equal to e to the x. Let's use that discovery to find the slope of this function at the point x equals 0. What's the derivative of 2x? What's the derivative of e to the x? After you find the derivative, evaluate it for x equals 0. Now e to the 0 equals 1, and so when the dust settles, I get 3/2. The slope of the line tangent to the graph at x equals 0 is equal to 3/2. Let's find where the curve has a horizontal tangent line. To do that, I set my derivative equal to 0. Solve for e to the x. After you solve for e to the x, take the log of both sides. You find that x is log 4, or about 1.39. We found that at x equals 0, the slope of the line tangent to the graph is equal to 3/2. We also found where we have a horizontal tangent line at about 1.39, log 4. Since the derivative of e to the x is e to the x, the derivative of e to the u is e to the u prime. So we can do something as complicated as this. Let's first find the derivative of the function. Remember, it's e to the u prime. So derivative, e to the u prime. What's the derivative of cosine pi x? Well, the derivative of cosine is negative sine. But now I have to take the derivative of what's inside the pi. What's the derivative of pi x? That's just equal to pi. Then clean up. I like to put my trig function in the front. After you find the derivative, evaluate it for x being 1/2. That was the instructions to find the derivative evaluated at 1/2. Sine of pi over 2 is 1. Cosine of pi over 2, that's 0. E to the 0 equals 1. And so I get negative pi. I'm going to need to use my quotient rule for this. Set up your quotient. The derivative of e to the t is e to the t. The derivative of e to the 2t, I need to use my chain rule. E to the 2t times 2. Put in the derivatives that you have found. Distribute that e to the t. Use your power rule. Combining, if you have the same base, you just add powers. Combine like terms and pull your negative out front. Since the derivative of e to the x is e to the x, the antiderivative of e to the x is e to the x. If you're using the substitution rule, it's still going to work. Let's do this one. This one's not too difficult. We'll start off with something that won't tax us too much. Let u be 4x, then du equals 4 dx. So instead of dx, I'm going to do 1/4 du. Make your substitutions. After you make your substitutions, now the antiderivative of e to the u is e to the u. Remember to substitute back. This one is harder. But again, have u be your exponent. What's du? After you find du, you need to go back and look at your integrand. Let's just rearrange things a little bit. I have dx over radical x. So solve for that. That's equal to twice of du. So instead of dx over radical x, put in twice du. Instead of radical x, put in u. Integrate. Then substitute back. One more problem. Now here there's not an obvious choice. Let's go ahead and choose the denominator here. See what happens. Let u be the denominator. What's du? Oh, I've got du right there up in my numerator. So when I make my substitutions, I see that I have du over u, and I know the antiderivative of that. After you find the antiderivative, substitute back. I do not need absolute value signs because e to the x is positive. Take care. Have a great day.